All right. So in project 2, we're going to work with a push button and learn about something very important in digital electronics, which is the pull up and pull down resistor concept. And this is actually more important than it looks. Because when we use a button as an input with Arduino, we can't just connect it directly and expect it to work properly. So the main problem happens when the input pin is not clearly connected to either high or low. When the button is not pressed, the pin is basically floating, and then it can randomly read high or low because of electrical noise. And that situation is called a floating state. And then when that happens, your LED might blink randomly or your system behaves unpredictably. So to fix this problem, we use something called a pull-down resistor or a pull-up resistor. Now, let's talk about the pull-down resistor first. In this setup, we connect one side of the button to 5 volts, and the other side goes to the digital pin. And then we connect a 10 kilo ohm resistor from that pin to ground. So what happens is when the button is not pressed, the resistor safely pulls the pin down to ground. So the Arduino reads low, and then when we press the button, 5 volts goes directly to the pin, and it reads high. So the default state is low, and press state is high. And then for the pull-up resistor, it's basically the opposite logic. We connect one side of the button to ground and the other side to the digital pin. And then we connect a 10 kilo ohm resistor from the pin to 5 volts. So when the button is not pressed, the resistor pulls the pin up to high. And then when we press the button, it connects directly to ground, so it becomes low. So here the default state is high and press state is low. Now, the good thing is Arduino actually has a built-in pull-up resistor inside the microcontroller. So instead of using an external 10,000 resistor, we can just write input underscore pull-up in the pin mode. And then the internal resistor will activate automatically. But one important thing is that the logic becomes reversed. So when you press the button, it reads low, and when you release it, it reads high. So basically in this project, we're not just turning on an LED with a button. We're learning how to stabilize digital inputs properly, how to prevent floating signals, and how to design reliable input circuits. And then this concept becomes very important later when we build more advanced systems like door locks, automation systems, robots, or IoT projects. So this is actually a small project, but it builds a very strong foundation for everything we're going to do next. If you enjoyed it, don't forget to like and subscribe so you don't miss the next Arduino project. See you in the next one.